Hello, everyone. It's a pleasure to be back with the Let's Talk Climate Change series, and we're very pleased to welcome Dr. Alok Bhargava from the University of Maryland. And he's been visiting Bangalore, very generously offered to come and share his time with us. Professor Bhargava has a very interesting and illustrious career as an economist. He did a master's and a PhD from the London School of Economics and has taught in a number of places, including the University of Pennsylvania, in Houston, and he's been a visiting professor at Harvard University, at the University of Paris, and visited a number of places and talked about economics, and evidence-based economics and data-based economics is really where his heart lies. But I also find it very interesting looking at your background that he's been very interested in the interface between economics and food security, economics and public health, and I think recently also economics and climate change, which is, of course, all of this is interrelated, right? Climate change, food, health, nutrition, all of this together. And when we were talking briefly before this, he said if you want to categorize his work in one way, he'd say he's very interested in looking at evidence-based analysis of climate change. So maybe we'll start there, Alok. Welcome. It's a pleasure to have you here.
Well, thank you very much for having me, and it's my pleasure to be here. I've moved recently into climate issues. Actually, the first paper was in 2018, and it looked at rice production and groundwater depletion in India. Because India is one of the few countries where we have data on wells, the depth in about 36,000 wells. And you could use remote sensing data like from GRACE satellites, but the resolutions are very low. So they cover 200,000 square kilometers. And so I kind of started analyzing these agricultural relationships and realized that not enough emphasis was being placed on actual measurements in the climate field. And I've spent, 40 years of my life or more on analyzing longitudinal data sets. And there are quite a few longitudinal data sets in climate field, except they're not available because people are used to using, various models, and, they have some values for parameters which may or may not be justified.
So I'll stop and ask you what longitudinal data sets are, because many of our viewers might not know.
So we want to see, when we talk about temperatures, climate change, we want to see how the temperatures are evolving over time. Now, take, for example, the IPCC report, and, the objective is to meet the goal of keeping temperatures below 1.5 degrees centigrade. Now, it's not well defined how they got that goal, but the problem is that Earth is a large place. The surface area is something like 196 million square miles. And surely there are more temperatures than a single sort of a temperature anomaly, which is the deviation from some arbitrary mean. So the issue really is, what is really going on Earth? And if you look at data from weather stations, now there are approximately 100,000 weather stations, and they're measuring temperature, humidity, and so on a daily basis. And now, of course, there are maybe 15,000 which are operational. So when we say longitudinal data, we're looking over time what is happening to temperatures. And these data are not available easily, but I was very lucky. They showed me the website, and my student downloaded them. And
This is Copernicus.
No, it is not in Copernicus. It's a NOAA data series or from somewhere. And it's, they just report what is happening globally to one average temperature. But is it the case that, the tropics are heating up much more rapidly, for example?
Right.
And what about different seasons? Is it the case the winters are becoming warmer and the summers are becoming extremely hot? So I think what I started with was groundwater depletion in India, and I presented that paper at the Swaminathan Foundation, and Dr. Swaminathan, who's passed away recently, he was a very generous person, and he started telling me that, you are the only person who's got this right, because everybody's making assumptions, and you're not making any assumptions. You're just telling me which parts of India groundwater is depleting at what rate. And so he thought this is the way to go. I mean, he was a very eminent scientist.
So this is what you mean when you say evidence-based, right?
So that's what I think is evidence-based. I mean, I cannot assert. So, for example, if I make the statement that India is depleting groundwater at unsustainable levels, it's a very broad statement, but I could then qualify and saying, well, the situation is particularly bad in central parts of India and where the monsoons are lower. But if you look in my paper, the west coast and the eastern coast, the groundwater depletion is actually at a slower rate. And because the recharge is available through heavy monsoons and so on. So I think Dr. Swaminathan was very impressed with this idea that, okay, you can have the green revolution, you can produce a lot of food, but if you're depleting groundwater like they're doing, for example, in Haryana, Punjab, and so on, and especially using water inefficient crops like rice, then, there is a limit to how far you can go with this. And so that's what I mean by evidence-based, and that's what I mean by longitudinal data sets, because what is happening over time? I mean, is it the case that global temperatures are increasing in both hemispheres, in all quarters? Yes, it is the case. But, to get to that point, you've got to analyze a lot of data sets, which can be downloaded, but then you've got to process them longitudinally. So, for example, I've been working with quarterly data. So you have quarterly observations on, temperatures, humidity, and so on. And but there's a lot of variation because of all these ocean currents. And so you can't really say that, that every year the temperatures have been going up at a steady, 0.1 degree Fahrenheit or centigrade, because then you need to start working with averages. What is happening every 3 years, for example? And in general, temperatures have been going up. And, I have a paper in the Royal Statistical Society showing that as carbon dioxide concentrations increase by, say, if you double them, the ambient temperatures go up by about 5%. Now, it doesn't look very big, but 5% increase in ambient temperatures is actually quite high. A lot, But I've also been looking at sea surface temperatures, which are going up even faster. So I think the IPCC and others, they need to take into account what is actually going on.
It's not just future models, but prediction. I mean, past calculations and near future predictions, right?
That's right. And, the sea surface temperatures have to be assessed or measured by remote sensing methods.
There's no other way to do it.
And so it's not that straightforward to analyze these data, because when we talk about poles, the North Pole, the South Pole, sometimes they're processing the signal based on, how thick the ice may be. And so in some sense, it becomes a bit circular, the reasoning. So, for example, they sometimes use, sea surface temperatures or temperatures, ocean temperatures of some kind to predict ice thickness in some models. And so you can't relate then ice thickness.
But you've used ice thickness to calibrate the model and tell you the temperature in the first place. Is that it?
Well, it's possible for some regions.
So you're basically using the same data as the input and the output, and to measure.
That's right. So you're confounding the problem. And then if you try to say, oh, sea ice thickness is going down because sea surface temperatures are increasing, you might say, well, there are some common underlying variables to both. And so your regressions are spurious because you've overlooked them. So I've been trying my best not to overlook any of these connections and try to, try to really, in fact, it's actually quite disturbing in the sense I just told you that if you double carbon dioxide concentrations, my models are predicting, these are actual, estimates. They're not based on any assumptions. They're predicting about 5% increase in average temperatures, but sea ice is actually declining at a very high rate due to increase in sea surface temperatures. So, for example, if you increase sea surface temperatures by 10%, you have a sea ice thickness reduction or sea ice concentration reduction of about 20 to 30% in the northern and the southern hemisphere. So I think we are heading in a very dangerous, we are on a very dangerous path in the sense that as the sea ice disappears, eventually so will the glaciers and polar ice and so on. But the fact is that the Earth's heating rate, this has been argued also in some science papers based on assumptions, that Earth's heating rate is actually increasing. And so I think that, to hold temperatures even to 1.5 degrees centigrade is actually a very complicated and challenging task.
Absolutely. And I think it becomes challenging for those of us looking at data because there's so many kinds of data. So I was very fascinated by your papers. You're looking at ocean surface temperatures, right? And you're looking at glaciers. You're looking at agriculture crop productivity. You're looking at wells. You've also looked previously at nutrition data and people's health status. And each of these data comes with its own set of assumptions. Like you said, you can't just take the data, process it, add it to another data set. I mean, you can and put it together and run it, but you'll be doing a disservice because you need to understand how the data was created, what the limitations are, what can it be used for, what it can't be used for. Sometimes, you have data from, and you know this, but this is for readers who might not know, that you might have data which looks very nice and evenly spatially distributed, but it's actually very clustered. It was in this place, and the software has done something to interpolate, so it looks like a continuous map, but they've actually interpolated and filled in the gaps in the bit in between. And that area is not very rigorous. And then you're making assumptions based on one error in one data set, another error in another data set, it multiplies. So as someone doing this kind of analysis, and a lot of our listeners will be young people getting into careers, two questions I have. One is, what gives you the courage to dive into different data sets? Because it is an act of courage and an act of faith. We do this all the time, but I see many people not willing to do this because they say, no, I know this area, this is my core. I'm comfortable here. I don't want to spread into areas I'm not comfortable because I don't want to make a mistake. And so that's my first question. And my second question is, if then they say that they're going to start looking at other things because climate change is an interrelated field, what should they watch out for? How do they train themselves to be rigorous?
Well, I mean, research is in some sense a public good. And I think we should all aspire to do as much rigorous research as we can. But the problem is that this idea that there's a catch-all interdisciplinary term, it doesn't work in public health. It doesn't work in nutrition in the sense that, in some sense, you've got to understand all the issues yourself when you're analyzing the data. So let me just take up your example of glaciers. I've just finished a paper. Now, there are remote sensing data on glaciers, and there are papers published in Nature and Science which are saying how the glaciers are actually thinning over time. And in fact, they measure the changes in glacier heights. And, you made the right point about interpolations. And in fact, you have a benchmark in some sense, though not very rigorous, which is you have the Glathida database, where they actually measure the thickness of the glaciers. The problem there is that they don't repeat the thickness measurements on the same glacier later in time. So you don't actually have longitudinal data. But what they do is they measure the glacier thickness at different points of the glacier. Now, if you look at the remote sensing data, it seems that the glaciers will actually disappear in a very short time. And this is partly due to the interpolations that these people have used to assess. Now, there are all these issues of stereoscopic measurements and correlations. And, they come up with algorithms that how to adjust for heteroscedasticity, which depends on elevation. And by the time they've finished with the data set, or they've constructed the data set, it's not clear what is an original measurement and what is the process management. So I've been looking at this, and if you look at the Glathida data, the problem is you're not repeating the observations on the same glaciers. So if you look at the Glathida data set, actually the decline is very nominal. Now, I'm not saying it is actually nominal, it is true, but in fact, what the Glathida people should be doing is they should select a subset of glaciers all over the world and observe them, say, annually, biannually, every 3 years, so we know what's happening. Whereas if you actually look at remote sensing data and you process them so much, you may come to, the wrong conclusion. Now, I think the issue is, how fast are these glaciers melting? And, I think they're melting at a slower rate than what these remote sensing, these papers in Science and Nature, what they're claiming. But it's faster than what you would think from the Glathida database, which is in situ measurements. So now to come back to your general question, I mean, when you're doing research, there are a lot of resources going in data collection. So somebody has to analyze the data. And when you analyze the data, for example, if you're working in public health or nutrition, which I worked for almost 30 years, the data are not, they're based on all kinds of human interactions, so ecological methods and, all kinds of social sciences, economics, and so on. So the issue then is, can we actually use all our a priori knowledge to postulate some empirical relationships and then estimate them and see, what would be a sensible evidence-based policy? So I think I've been doing that in sort of the field of nutrition, psychology, demography for a while. But climate now has become really urgent issues, I think. It is a bit naive to think that that everything can be sorted out by just looking at some carbon dioxide concentrations in the atmosphere. The ocean currents are really the key here. And what is happening is that you have remote sensing data on ocean surface current velocities for both the northern hemisphere and the southern hemisphere. But there's the interaction between deep ocean currents and surface currents, which there are no data practically on deep ocean currents.
Right.
And so I've been actually using moorings data for the AMOC, which is the Atlantic Meridional Overturning Circulation. So for example, it is the current which flows from Atlantic around Africa towards Greenland and then comes back. Now, the hypothesis is that this is a single current and it takes 1,500 years to return. But, there have been people like who've argued, like Stomel, for example, that it is not a single current. It's a layers of different currents, and who knows how many multiple equilibria there may be.
Wow. And so, you're not modeling it for that. You're modeling it as one current.
Yes. So what I did was I looked at AMOC measurements around 35 degrees north collected by Isabella D. Labras, and they sent me the data. And, there have been papers in Nature Communications, for example, saying that AMOC is slowing down. There are papers all over the place, but they're very misleading. In fact, that paper in Nature Communications, it actually doesn't even have data on AMOC. It has data only on sea surface temperatures. And where people have data on AMOC is a very large current and sets of currents presumably. And you need to measure AMOC at different points, and that too longitudinally. So that comes back to my point about longitudinal data. So when I looked at AMOC, I mean, it covers something like 500,000 square miles, or maybe a bit less. And I sort of created another database to merge it to look at sea surface temperatures in that area. So you can actually see what's happening is that sea surface temperatures per se are not really driving AMOC speed, but it is actually the ocean eddy kinetic energy. So basically, if you look at surface currents, you have zonal and meridional, and if you square them, you get the eddy kinetic energy. And now, there's this big complicated interplay. Now, I'm a statistical methodologist.
I'm just thinking of this as you're telling me all of this. How on earth would you figure this out? Because this is not something you've learned. It's not something that is part of what, let's say, you did your PhD on.
Well, actually, it is, ironically. I am a statistical methodologist. And all our econometric training, I worked with a very eminent British econometrician. And, he was very far-sighted. And there were people like John von Neumann, one of the great mathematicians of 20th century, Norbert Wiener. So these were the sort of works we were taught when we were in PhD levels. And that's what I did my PhD on. So I think that the issue then was, von Neumann was one of the persons, coming up with the computer and how to replicate, how to have... how to get these repetitive tasks done by a computer. But of course, von Neumann was also involved in the Manhattan Project. And, I don't think he did his reputation any favors.
Right.
But, the fact is that they were worried that the computational methods will never get, or how can we take the computational methods to a level where we can actually analyze data and improve, whether it's economic productivity, whether it's human well-being, and so on. So I find myself, 40 years after my PhD, or maybe 45 or whatever, that, you have to look at all the data sets that are available and see what is happening. And no discipline has monopoly over any of these analyses.
Absolutely.
But unfortunately, the US especially is a very specialized place. And, if you go slightly outside your own discipline, people are not interested in your work. But if we look over a century, the population has greatly increased from something like 1 billion or closer to 2 billion to almost over 8 billion now. And our living standards have increased. So it's effectively like the population has increased 10 to 20 fold in terms of consumption.
Exactly.
And, it cannot, we are depleting groundwater, especially in countries like India. And right now, the crisis doesn't look so bad because, if you go back to Indus Valley civilization, they had all these groundwater recharge policies.
Right.
So, in fact, by the time we got to the Mauryan dynasty, they even had a non-linear tax on water. So if you extracted more water than you needed, you had to deposit some of it to other people, to a central body. So I think India has a very rich history. The problem is that we are all confused. And, it seems that between 1100 and say 2000, we've sort of forgotten what our past was. And we are all in awe of countries like in the West, like the British colonialism and so on, who exploited India and made sure that India didn't grow for a long time. But, we've always had great philosophical and intellectual potential for much before any other country.
So you're from Rajasthan, right?
That's right.
Did you grow up in Rajasthan?
Yes, I grew up in a city called Alwar, which is between Delhi and Jaipur.
And how does that shape? I mean, the tradition. Alwar has a lot of these step wells and areas.
Well, not really. It's more a princely state, and so I went to a boarding school, Mayo College, Ajmer.
Did any of the influences you had growing up influence the fact that you're looking at water right now?
Well, the thing is that in Alwar, the water wells, when we dug a well in 1970, water was at 55 feet. Now it's around 400 feet. And, I was in a boarding school in Ajmer where there was no soft water, so there was the hard water. And the wells ran very deep. And so, I've been very aware of water shortages. In Rajasthan. But, the thing is that in some sense, it takes a fair amount of technical training and also some imagination, I guess, to formulate these relationships. And, we are heading towards a crisis. And in fact, India growth rate may be very impressive, but we are doing a very poor job in terms of unwanted fertility in rural areas, especially in the Bihar, Madhya Pradesh, Rajasthan, and UP. And we are depleting groundwater very rapidly. All these aquifers are not being charged. Now, for example, Maharashtra has some schemes to recharge aquifers, and they do have a lot of rainfall. But, the aquifer charging in the northern states is really not adequate. And it's just a matter of time when even Chennai is actually depleting groundwater.
Absolutely, yeah. And it's ridiculous that a coastal city with the wetlands that it had and the capacity for recharge that it had is running out of water, right?
That's right. And Dr. M.S. Swaminathan, I knew him quite well, and I knew people like Nevin Scrimshaw, who was a very famous nutritionist. And they're talking about improving agricultural productivity through technical innovation and so on. But at the end of the day, we've got to worry about groundwater. So, for example, the scientists sometimes don't help the cause. So there's an article, the so-called EAT Commission in Lancet, and they're claiming that we can feed 10 billion people nutritious diets by 2050.
I saw that, yes.
Now, I have a negative view of that, which I published in British Medical Journal, a very short comment. They don't even mention the word groundwater.
Yeah.
So how
are they?
They've got some very obscure theory of nitrogen recycling, which cannot deliver. So I was very actually touched that Dr. Swaminathan was so impressed And you made me promise every time I come to India, I have to come to the foundation and give a talk. And so I said, all right. I mean, you're an eminent person and you're inviting me all the time. So why? But the point is that we can improve diets, but as you switch to more nutritious foods, animal products, and so on, the water consumption is very high. So that's what I've done in the unpublished paper that I sent you. But the problem is that people, when a paper gets published in the Lancet and it's cited 3,000 times in 3 years, everybody thinks it must be very important. But is it? And the fact is that I think the scientists need to be much more accommodating. There's this tendency of over competition in the United States. So there are these groups, and if they can get their views across, then it's very hard to change anybody's mind. And I think developing countries are the main sufferers in this sense.
And that brings me to one of my last couple of points. One is, I think, what we're seeing increasingly with climate change, especially in developing countries, and India is an exception. We have very strong science community, so we do a lot of our own work, of course. But many other parts of the world, you'll see that what happens in that part of the world, like take Africa. So much of the research on Africa is by the West and not necessarily relevant to the African context. And so it drives policies, it drives action, but it's done from a perspective that doesn't necessarily know all the nuances. And it relates, so that's sort of the...
That may be true, but I think this idea that who's doing the research, I think in some sense is not as important as what research is being done.
But do you think if you don't know the context of a place, especially something as complex as, let's say, nutrition, food, climate change? I'll give you the example that I'm thinking of. So there was a paper, and this was about 10, 12 years ago, one of those let's feed the world sustainably kind of paper, but from a land use, land cover change scientist, very well-known one. I won't take his name. But it was talking about reorienting parts of the world. So part X is, let's say, growing sorghum, which is one of the millets in your study. I'm using sorghum as an example. Let's make them grow something else instead, because this landscape is much more suited to that. And then I was talking to Eduardo Brondizio, who is a colleague and a friend who is an anthropologist in Indiana University. And he works on Brazil, and he's from Brazil. And he said, there was this natural experiment of sort by these people. So in the areas around the Amazon, which are urbanizing very rapidly, they said, what you're growing is not the best thing that you should be growing. And they made them grow something completely different. But the thing is, there are no markets there, and people eat what they're used to eating. So when you make them change their cereal crop or their mainstay to something that's not part of their diet, you have this glut which is not sold. People don't know what to do with it. So it was a disaster, productive. Maybe it was more food productive, but this assumes that food is not culture, food is not diet, food is not part of yours. So that's what I mean.
No, I agree with that. And I think the anthropologists are very interested in everything. And so, if you look at nutritional studies, they usually have not only a nutritionist, but they also have some anthropologists.
Right.
So I named Nevin Scrimshaw. In fact, his wife was a medical anthropologist, or his daughter is a medical anthropologist, Susan Scrimshaw. Mm-hmm. His wife was an anthropologist. So, no, they developed Inca Perina for South America in the context of culture and so on. So I agree with you what you're trying to say, that, if people have no idea of the culture and the local tastes and so on. So I've been working, in fact, Harvest Plus is a very big program with they had a budget of something like $250 million a year. Mm-hmm. And it started with a paper that I wrote with Nevin Scrimshaw and Howdy Booth. And, they started producing iron-dense rice through plant breeding, iron-dense beans, orange flesh sweet potatoes, which are familiar to the local populations. And then they started giving free these vines in Mozambique and other African countries and so on. So it's all based on cultural settings. Right. Now, maybe you might say, well, these people are all Americans and so on.
That is fine, I think.
But that is fine. But I mean, I agree with your basic point.
They're collaborating with people. They know the context.
Yeah, but the thing is that even in India, I mean, it's very, or in most East Asian countries and so on, it's very hard to get people to consume different staples.
Yes.
Rice is a staple, but rice is not water efficient.
Yeah.
There's the stubble burning. But the point is that India needs to get serious about growing rice, and coastal regions are ideal, of course, with all this high rainfall. But now with rising sea levels, there may be salinity may increase, and who knows what's going to happen. But yeah, you shouldn't be depleting groundwater in Punjab and Rajasthan or Haryana to grow rice. And I think that it's true that it's good if people are culturally sensitive.
We probably need to go back in India to the tradition that we did have, which was of growing millets. I mean, I'm again
That's
picking
right.
up sorghum from your paper, but
Right.
seems like those kinds of sorghum, bajra, jowar,
Yes.
all of those things, ragi in Karnataka, those are the things that...
Yeah, in fact, Scrimshaw, if you look at South America, I mean, the whole nutritional situation really improved. He went from MIT and he lived in Guatemala for 10 years. And, they had these fortified gruels. So, for example, in India, we hope that all children can afford milk. But, if we are going to deplete groundwater and dairy production goes down, then, we can learn from some of the plant-based supplements they had. They used things like cottonseed and, sorghum. They came up with these gruels, which actually increased not only the heights of the supplemented children, but even of the next generation. So, I mean, the problems are complex, and, I think that there's too much emphasis in research, especially in the United States, in the short run. I mean, everybody's looking for grants and, trying to see what is fundable. Let's move on to what is, but these problems are not going anywhere, and we cannot solve them.
So that then brings me to the last thing. Since there are many young people watching us, and you're saying that climate change may be one of the last sets of problems that you want to work on because it's complex, I think, enough to occupy us for a lifetime. And certainly we know that the world is changing very fast. What are the big unsolved areas that you think people should be looking at in India?
Well, groundwater is one, but I mean, I've put in all my unpublished results in these two papers that I sent you. But the fact is that we will have to reorient our, the level of industrialization has to it has to be a function of the resources that are being consumed and at what rate, and especially, water resources and so on. So, but then there are all these unresolved areas like, desertification. So, countries like India may think we can go for a 10% growth rate, and we can compete with China, which is 3 times our size and has all the rivers flowing from China to India, not the other way around. So I think that we need to know what is sustainable. And, I know you're very, knowledgeable about all this, what is sustainable. But the fact is that, somehow we've got to orient our research. Now, there are some data sets on desertification, but they're very elementary. There's remote sensing. Then there's this permafrost loss, for example. Yes. And I think glaciers are very important, and especially for countries like India and China. And I think, once Manmohan Singh, whom I know a little bit, I guess, since I know Amartya Sen, and, they were kind of in PhD cohort together at Cambridge. Manmohan Singh once said that there's enough room for India and China to grow, but, are they really looking at the resource constraints? And I think that is the critical thing. So I think the next few generations, they've got to sort of get out of this idea that we can model relationships based on some assumptions. And after that, whatever is the output from these models becomes data. It is not data. It's projections. It's full of assumptions. And I think Swaminathan was very impressed with the idea that you don't take any assumptions for granted. Right. I mean, either you show it or you don't talk about it. Yeah. So I was actually quite touched that somebody like him was very encouraging to somebody like me, who's, very technically minded person, statistical analysis. Yeah. So I've gone on this thing, but I think this is the next generations. In fact, there's a quote from Max Planck, which says something to the effect that academics don't change their mind, they just die. And then a next generation comes along and they know it's not true. And so, but, we hope that the next generation will actually focus on what is measurable, how is it evolving over time, what are the complex issues the society is facing in terms of health.
Fantastic. I think we started with data-based climate change, and we've come back to data-based climate change in a very different way, but it's been a very fascinating conversation. So thank you so much. It's been a real pleasure having you.
Thank you for asking me.